So the last three problems on the review are in their own section because I consider them to be kind of challenging problems. Not that they're that difficult, but they do require multiple steps to solve. Sometimes you have to solve out two different things and then operate them together or something like that. So let's take a look at number 16 here. You can see there's a couple different triangles going on here. We do have a right angle, so we do have some right triangles. Ultimately, we're trying to solve out this length here, just the length between D and C. So there is a temptation. I've seen some students in the past, they try to do some calculations with this triangle, try to solve x directly. And the problem with that is that triangle BDC is not a right triangle. So we can't use Pythagorean theorem, we can't use sine, cosine, tangent, we can't use 30, 60, 90, or anything like that. So we can't solve the value of x directly. We have to use the right angle and the right triangles. So you might notice that one of the easiest things to solve here would be the length of AD. We do have a right triangle with BAD, and we know two of the sides of that right triangle. So it would be pretty easy to find out what the length of AD is. So let's start there. So 14 would be the hypotenuse of this triangle. 10 and whatever this length is would be the legs. So I'm just going to go ahead and call this the length y, and we'll use that to help us solve. So 10 squared plus y squared would be equal to 14 squared. So that would be 100 plus y squared equals 196. Then we want to get y squared alone, so let's take the 100 over by subtraction. So 196 minus 100 would be 96, and then finally, if y squared is 96, then y by itself would be the square root of 96. And we don't actually have to know what that value is. We can just use the square root of 96 and put that in here. So now we know that that distance is the square root of 96. How are we going to solve out the value of x? Well, you might notice that there's actually three different triangles here. So we already talked about this one that we can't work with. We worked with this one, BAD. There's also the really big triangle BAC, and that happens to be a right triangle as well. So we can use that to solve something. Specifically, we can solve the distance out all the way from A to C. Figure out what that is. So I'm going to call that variable Z, and let's solve for that. So if you're looking at this as a big triangle, we've got a hypotenuse of 16, a leg of 10, and then a leg of Z. So let's pop that into Pythagorean theorem. 10 squared plus Z squared equals 16 squared, which gives 100 plus Z squared equals 256. Get Z squared alone by subtracting the 100 over. And finally, if Z squared is 156, then Z itself is the square root of 156. So now we know the length of AC is the square root of 156. Now you can probably see what we're going to do to get the value of x. All we have to do is subtract the longer length AC, subtract the shorter length AD from the longer length AC, and that will give us what we're missing right here. So DC is going to be equal to the square root of 156 minus the square root of 96. You can go ahead and do that on your calculator, since subtracting square roots is not necessarily the easiest thing to do. And you find that this value comes out to be approximately 2.7. And that's your x value. Let's move on to the next problem. All right, in number 17, once again, we have multiple triangles. This time we don't have any overlapping triangles, which is nice. Ultimately, you'll notice the x is the angle. The x stands for the acute angle in the upper triangle here. So that is what we are trying to solve for. Now, if you look at that upper triangle right now, you'll notice that the only thing we know about that triangle is that the hypotenuse is 12. we don't have either of the other two sides. We don't have either one of the two acute angles. So Pythagorean theorem, sine, cosine, tangent, nothing will work on this upper triangle. So that's a good clue to us that maybe we need to shift our focus down to the lower triangle. We actually know some information about the lower triangle. We have a side and we have one of the acute angles. That acute angle is a 25-degree angle, so it's not one of the special angles like 30 degrees or 60 or 45. So this is going to be something that we could solve using sine, cosine, and tangent. Now specifically, we're trying to solve something in the upper triangle, so I think it makes the most sense for us to try to solve out this length right here. If we can solve out what y is, then that will help us continue on to solve out what x is. So let's start off here. If we're looking at the 25-degree angle, that means that the side length 2 here would be the opposite side, and then y would be the hypotenuse for the lower triangle. So which trig ratio uses the hypotenuse and the opposite side? That would be sine. So sine of the angle that we're looking at, 25 degrees, is equal to the opposite side, which is 2, over the hypotenuse side, which is y. Then you go ahead and solve for y. So multiply y over to this side, which would give you y times sine of 25. That's equal to 2. Then to get y alone, you're going to have to divide that sine of 25 over to the other side. So you would get y equals 2 divided by the sine of 25. All right, so you're going to have to put that in your calculator. Anytime we use sine, cosine, or tangent, we always put it into the calculator. So this is going to come out to be approximately 4.7. Now, I'm actually going to round this off to 2 decimal places because I'm eventually going to use this number to calculate something else. And anytime you use a rounded number to calculate something else, you'll find that the numbers can get really inaccurate really fast if you round it off too much. So I'm going to go ahead and leave that as 4.73, and we'll put that in right here. All right, now we're going to shift our focus to the upper triangle. Now we have enough information to solve for the angle x. So we have a side length, actually we have 2 side lengths. Now in the upper triangle, 12 is the hypotenuse, and if we're looking at angle x, 4.73 would be the adjacent side. So we have an adjacent side and a hypotenuse. Which trig ratio uses the adjacent side and the hypotenuse? So that would be cosine. So we write our equation. Cosine of the angle, which would be the x, is equal to the adjacent side, 4.73, over the hypotenuse side, 12. Once again, we see, hey, we don't know what the angle is. And anytime you don't know the angle, you can't use the normal sine, cosine, tangent. You have to use the inverse sine, cosine, tangent. So we flip it. Instead of plugging in the angle, we plug in the ratio. So cosine inverse of 4.73 over 12 is going to be equal to x. Use your calculator to solve that out, and you will get the value of 66.8. And for this answer, for the ending answer, we can actually round it off to 1 decimal place because no other answer in here is going to depend on that answer. All right, let's move on to the last problem on the review. All right, for the last one, again, you'll see that there's multiple triangles here. Ultimately, we're solving for the length of AP. We really don't know anything about this triangle over here, although we can, figure out that that is a right triangle because of the linear pair of angles there. We know that the whole length NP is 9, but we don't know just what this length is. We don't know any angles over here. So we're definitely going to start over in this side. So here we know one side and we know one angle. It's not a special angle, it's just 50 degrees. But we can use that 50 degrees and that side length to solve either one of these 2 sides. So let's go ahead I'm guessing because we have the 9 down here, it probably would be smart for us to solve this side, because if we know what this side would be, we could solve this side out. So let's start with that. Let's call NT our y value. All right, so compared to 50, this would be the adjacent side and the hypotenuse side. So cosine uses the adjacent side and the hypotenuse side. 50 degrees is the angle we're looking at. Y is the adjacent, and 3 is the hypotenuse. Multiply by 3 on both sides. So whatever 3 times cosine of 50 is, that is what y is going to be equal to. So checking your calculator, it comes out to be approximately 1.9, but I'm actually going to round this off to 1.93. Again, we're going to be using this value to calculate something else, so I'd rather be a little bit more accurate this time. So that's 1.93. Obviously, we can just do 9 minus the 1.93 to find out how long the length of segment PT would be, and that comes out to be 7.07. So that would just be that little part right there. All right, now let's recheck and see, is that enough information to solve for x? So now we know one side length in this triangle. We need to know another one, but it's still missing too much information. We don't have any angles, any of the acute angles, and we're missing that other side. So we do need to go through and solve for AT. We can do that using the 50 degrees and the side length of 3. So let's have this be the next thing we solve for. We'll call that Z. Compared to the 50 degrees, Z would be the opposite side, and 3 is still the hypotenuse. So opposite and hypotenuse, the sine ratio uses opposite and hypotenuse. So that would be sine of 50 degrees would equal the opposite side Z over the hypotenuse, 3. Once again, we multiply by 3 on both sides, and we find that Z would be equal to 3 times the sine of 50. All right, so let's get that value. That comes out to be 2.3. And if we round it off to 2 decimal places, it actually comes out to be 2.3 regardless, even if I round it off to 2 decimal places. So this side comes out to be 2.30. Now we have enough information to solve for x, because we know 2 of the side lengths of this right triangle. Anytime you know 2 of the side lengths of a right triangle, you can use Pythagorean theorem to get the third side length. So this 2.30 and 7.07 would be the 2 legs of the triangle, and then x would be the hypotenuse. So we're going to pop that into Pythagorean theorem. Use your calculator to figure out what 2.3 squared plus 7.07 squared is. That comes out to be 55.2749. Square root both sides to find out what x is going to be equal to. And again, you're going to use your calculator in this case to figure out what that is. So square root of that long thing gets us that x is approximately equal to 7.4. And there it's okay to round it off to 1 decimal place, because again, that is our final answer. We're not going to be calculating anything on that answer. So a challenging problem, just because it required us to solve out 3 different values before we could even find out what the thing we were actually looking for was. So the math was pretty easy, but you just had to be able to see which things you needed to calculate and how to calculate them. All right, that concludes our review. So hopefully these videos have helped you guys see mistakes or figure out what to do and prepare for the test.